Hello, I'm Cheryl Adams, and I'm a SQL content developer at Microsoft. When I think of SQL and machine learning services, they're very large topics. When I was given the opportunity to learn about machine learning services, it was a bit overwhelming. I considered, how could I take my knowledge and experience and move that into having more information about machine learning? Having a background as a data architect, as well as a DBA, I felt like I had a good foundation in understanding data. I created what I'd like to call connective learning points by asking myself the following questions. What do I know? What do I need to know? And how does that apply to machine learning services? This is what I know. In SQL, physical data files store data. I know that in a relational database, tables are used to store data based on a row and column format. I know that data consists of different types and columns to store that information. So now consider this. How can I leverage that information with machine learning? Can we use machine learning to analyze data? How so? We can learn by training and learning data using programmable models like Python or R. They have the ability to use historical data to forecast particular outcomes. You may ask, how does Python use, or how does machine learning use this data? Machine learning allows us to take multiple factors into consideration as part of our decision-making process. It gives us the ability to visualize what I like to call a subset of data. We will see this in our demonstration shortly. By placing data in a data frame, which is a two-dimensional data structure with columns, we can analyze data. So what we're doing now is discussing some of the connective points through a knowledge base that we already have to leverage that knowledge into machine learning services. Let's consider one of the primary components that's used in machine learning services. Python is one of the most used programming languages in machine learning. In fact, it's been said to be one of the easiest languages to learn. Now, before you start thinking, don't get disappointed or discouraged if that hasn't been your experience with programming. Everyone's experience is different. What I will say is that programming language is like telling a data story. The more often that you tell it, the more experience that you gain. And that's the same with programming. Also, there are a number of sources or resources that are available for you to learn Python. There are Python tutorials, there's Python books, there's even online sample code that you can use. You'll find at the end of this slide deck, I've included some links that describe some of the demos that we'll be doing today. Each one of those links includes installation instructions as well as sample code. Microsoft Docs is an excellent method for learning more about Python and how it works with machine learning. Let's consider another part, the package. Today, we'll be using a package called Pandas. Pandas is a software library package for Python. It allows you to manipulate and analyze data. Data placed in a data frame can be used to visualize or do calculations in place. In fact, you can take that data and place it into the database itself. Here's another connective point to consider. If you've worked with SQL or databases, I'm sure you're familiar with the select statement. With the basic select statement, we can give parameters about what we want to view. However, SQL can be very limited, or it can be cumbersome if we're trying to create select statements that are too complex. But take for consideration using select statements within Pandas or using Python. By using select statements within Python code using the Pandas library, you can actually do calculations in place in that data frame. You can create meaningful results and to help in your decision-making process. By creating this calculation and using data this way, you can provide insights to your users. Today, we're going to be looking at some examples using SQL Server and machine learning services. I want to bring out that this is an excellent example for portability. And what do I mean by that? That means that you can use SQL Server 2019 machine learning services and be offline. I think this is an essential way for you to get hold of learning more about machine learning without having to be concerned about a persistent internet access. Of course, you will need internet to be able to download all the components, but once you're done, you should be able to create models, do deep analysis and calculations without being online. So let's talk about that testing lab that we just spoke about. And again, all the information that you see here at the end of this slide deck, I'll have all the installation guides that you need. Today, we're using SQL Server 2019 for Windows. We are using the Windows version, but I wanted to let you know that it is also available for Linux as well. We also have instructions for installing SQL Server 2019 for machine learning services in a container. All of this information, as well as the documents and requirements, are found on the Microsoft Docs website. Another component that we'll be using today is sample data. Sample data is part of the instructions for the setups that we'll be doing today. So as I mentioned, when you get to the end of the slide deck, I'll show you a couple of the links that are there. Each one of the links goes through the setup instructions as well as how to obtain sample data. Now the tool. The tool that we'll be using today is Azure Data Studio. I'm sure if you've used SQL Server in the past, you've used Management Studio, and this is slightly different. Azure Data Studio not only allows you to connect to the database, but it also allows you to run code. My setup today has the Python kernel already installed, so we'll be able to run Python directly through Azure Data Studio. Why don't we get started, and I'm going to show you some of the tips with the tool and how it works. This is Azure Data Studio. Now, Azure Data Studio, as you can see, has a couple of different components that are here. Here we can see that there are servers that are connected. And what does that mean? That means that we don't need to use the Management Studio. All we do is set up our parameters, and I'm going to share those with you. And by setting up our parameters here, we can make the connection to the database. So here you see that I have two different environments that are connected. You can see that by the green light. You can also expand and see all the tables that are here. I could expand and see all the tables that are here as well. So there's our database connectivity. We can connect and disconnect. As you can see, the red light means that it's disconnected. The green means that it's still connected. But here's the interesting twist. We can also look at these tables directly through Azure Data Studio without leaving. So we can do a very simple select statement. And there's all the data that's contained in this table. And we haven't left the tool yet. This data, or this particular query, if we wanted it, we could save it in a notebook. If you're familiar with Jupyter Notebooks, this is a similar setup. We could take this query and we can save it into a notebook for future use. In fact, what we'll be doing today is that we'll be using two notebooks that I previously saved to show how Python works along with SQL Server. Let's take a look at that. I'm going to go to File, and I'm going to open Recent because I have already had it open. Well, actually, let's do this. Let's open the folder. Okay, and we're going to look at what's here. Well, Let's see, we're going to connect one more time. Looks like it disconnected, unfortunately, but that just takes a moment. Okay. Let's open that file. And let's take a look at this one. We're not going to run it yet, but I just wanted to walk you through what we have here. Now, although we already have our database connected, we see that within this Python code, we have our connectivity here. Here's all of our information. In fact, where you see this are the instructions for setting it up. And here are all of our variables. We're using PyODBC, which is the connectivity that allows us to connect to SQL Server. And there's that pandas library module that we talked about. That package is what's going to be used to create this data frame. So here we are taking information, and this is what we're going to do today, is what we're doing an insertion. So I have a plain text file, a CSV file, that's going to go into a table. And let's scroll over so that we can see that. Department test. Now I've created department test already, and that's a separate step. This particular piece of code, as well as the instructions for creating this table, are also part of Microsoft Docs. So all this is doing right now is taking this data, and we're going to insert it into this table called department test. We're going to execute from here, where it says run. And right now we're reading the files, well, this one particular file, and it's going to be inserted into this table. So now let's find that table, Human Resources Department Test, and validate our results. So we're going to look here. Here's Human Resources Department Test. That's the table that we referenced here. We put in this information that's showing. And now let's take a look. We can right-click on this table and select. The table was previously empty. And we're just going to do a basic select from there. And this is all the data that we loaded. All the data that was from that flat file has now been inserted into this table. Now, of course, another option we could have done is if we needed to, let's say this data was from another resource, maybe someone else that had done some work for us. We are still taking that data in and maybe putting it into the database so that other individuals could use it. We could expand this code and do calculations on this data, maybe modify this data, and still insert it into the table. As you can see, the code is fairly readable. We can follow the instructions, even not knowing Python or not being familiar with it. You could see that it's loading this table, this file rather. It's inserting, and there's that some of those common syntax for SQL, inserting into, and there's all the values that it's doing. One of the things that I like about using this particular language is I can take this and use this as a foundation for my story, right? I could take this into my business, into my department, modify some of these values, change the file, and do the same insertion process in my own business. This particular file, as I mentioned, as well as the instructions, are found in Microsoft Docs, and I'll show that link to you shortly. We were able to verify it, as you notice, without leaving the tool. We can still see SQL, we can see all of the tables. And because this table doesn't have any restrictions on it, we could, as a test, delete all the data that's here, rerun this, and the data would go right back into this table again. So as long as you know the characteristics and the data types and the fields of the table, you'll be able to do this same test in your own local environment. You don't necessarily need to download the sample tables, the sample tests. One example that I think is useful in your office is if you have the ability to clone a small table and extract that, export that data out, you can do a similar test. Let's take a look at another one. So this was an example of getting data into the database. Let's take a look at another example and see what we can do about visualizing data that already exists in the database. So we actually don't need to close that. We can just open another one. Oh, well, that one ran already. Let's see if we can. So here we have the same command, pi ODBC, which is our connectivity. Pandas again, we're still using the pandas. And we're also using matplot. But we could, and here's the whole example of here's the data. Again, let's find that select statement. Here we have the select statement that's here. There's the SQL that's used. And what this particular data is we're getting a age range. So we're taking the data from this particular table, fact, internet sales, and we're building a visual data of the ranges of values that are in that table. So what would you need to know to design this? Well, you would definitely need to know your data. So when you're trying to visualize data and creating a histogram, you definitely want to make sure that there's some frequency. Frequency means that there's some variations in the data. Selecting the right table is key for this. Again, this is another example of data and documentation that's available through Microsoft Docs. This code and this data is based off of one of our sample databases. So you can try this locally for yourself. You can build this environment, you can get the test data, and you can create a histogram like this. You don't necessarily have to use this table. I suggest you play around with it. Look at some of the data that you have, look at data that you know that there's frequency in, excuse me, and build a chart similar to this. This is quite simple, but you can certainly expand it. And depending on the more frequency that you have within your data, the larger that this chart will be. Let's talk about your setup, and part of the setup that I wanted to mention, so we've looked at 2 sample codes, but part of the setup that I wanted to mention to you is that you also have the ability to load packages as well. So one of the instructions that I'll be providing to you is how to load additional library packages. Each one of these packages was previously loaded before we started, so that's how that works. Now that we have these are saved as notebooks, so we can go through and we can modify them, we could change them, and we could save them. You may be used to running Python on a command line, but I find that this method is easier to edit and to retain. You also can look at the direct impact to your data as you're running it, something that's a little bit more challenging to do from a command line because you would have to switch to a different environment or a different tool. So today we've taken a look at a couple of different things. We've talked a little bit about SQL and machine learning services. We've built some correlations between having a background in SQL and machine learning and the differences between the two. We've talked about the setup and the portability of the setup, meaning that you can run this offline and you don't need a persistent internet connection to do so. We've also talked about the flexibility of this tool. Azure Data Studio can be used to access your SQL environment directly, but it can also be used to run code. We've talked about adding code with Python, as well as additional packages, which are available through the tool as well. Each one of these items can be saved as a notebook, which is helpful for us to go back and look at in the future. So today's discussion, we've covered what I like to call the foundation. This is not something that I could say this covers all of machine learning because it's fairly vast. There's a lot more attributes to it. There's a lot more that you can do. There's a lot more that you can do with Python. Our goal today was to not load you down with too much information, whether you're new to the field or a seasoned veteran of machine learning. What I wanted you to do today, or I wanted to encourage you to do today, was to look at SQL Server. Look at the robustness of this tool with machine learning services. Look how these things seamlessly can connect and work together. So I encourage you to look at our documentation, download the test data, try the developer model of SQL Server 2019, and bring these together. I encourage you to do this and to get started. I now want to share with you some of the information that I mentioned. And this is all of the documentation that I spoke of earlier. So here we have the documentation for the machine learning services for Windows. This is the installation guide. This is Azure Data Studio with the Python kernel that allows you to set up Azure Data Studio and then to use it with Python. Here are the two examples that include the code for one is inserting data from a SQL table into Python, and the other is plotting a histogram in Python. I also wanted to encourage you to take a look at our landing page for machine learning, which contains all of the docs, more comprehensive tutorials, as well as how-tos. Thank you. Any questions?
Yeah, hi Cheryl. Thank you very much for the amazing session. Very interesting. And like I have one question now. This is regarding the training of the data set. When it comes to training of the data set, like what are the advantages you see in the SQL Server with machine learning?
Oh goodness, I'm sorry, your video stopped a little bit. What was it that you said?
Yes, now when it comes to training the data set, now we know like with Python we can train the data set, like, so what are the advantages you see when it comes to training the data set with SQL Server machine learning?
Well, I think the key advantage of doing that training is that you have the ability to retain the historical data. So as you continue to train the data, you basically build a model that you can start to do comparative analysis as you go forward. So I like to call it like historical data. So once you train a model and you get that information, as more data feeds through, you'll start to see the trends of what that trained model looks like versus the new data that's coming in.
Right, okay, thank you for that. And also a little bit on the training part, like the most common, this is about the machine learning training, like most common terms that we have heard is overfitting or underfitting, and overtraining and undertraining. Like, can you give a brief explanation on that?
So you wanted to know the difference between overtraining?
Yes, yes.
Now, personally, I don't have a lot of experience with that, but I would say in general, some of the information that we have, so like if you visited the Microsoft documentation, some of the tutorials we have actually train the data. However, I think if you overtrain the data, usually when you do it, it's kind of a first pass where you get those results. But if you continue to train the data and you're putting in different variants of data, I think your results will start to get askew. So I think once you build that model and you're satisfied with that model, then what you're adding to that is just to build the trend. If you continue to try to push new training in, it's almost like you're resetting your historical data set, because you want to try to retain, like, this is my trained model, this is basically what I can predict will happen in the future. But if I continue to push more and more through, I don't have a historical reference because I'm continually replacing it. And ideally, what we want to do is gather enough insight so that we can make good decisions. But if we continually force it through to train, it's almost like we're resetting it and we're starting to lose the value of retaining that historical data.
Right, thank you very much. And we have another question. Cosmos DB or any other NoSQL, does the SQL Server machine learning supports Cosmos DB or any other NoSQL?
At this particular time, the SQL machine learning services it's working with SQL, but it also works with managed instance. At this point, I'm not aware of it working with Cosmos DB for NoSQL at this time.
Hopefully in the future.
Yes, but definitely that's something. Please, visit the feedback and put that out. They're definitely interested in hearing about that.
Right. Thank you very much, Cheryl, for a very interesting session. And thank you, everyone, for all the amazing comments and questions. So I think we can wrap up this session for now, but many to come. So Shiham, over to you.
Thank you.